Good morning. Many of you will have seen these solutions already because I've shared them with you, but just going through the submission questions from the live lesson. So if this was the first one, I'm considering the left-hand side. So I'm going to grid out these two brackets. Remember, you've got to resist the urge just to do that squared and that squared. It's this, isn't it? And particularly important to notice that 2 sine theta times 2 sine theta, 2 times 2 is 4, sine theta times sine theta, we write as sine squared theta. Interesting that Martin Lavelle said on Friday, he didn't really like it, but we have to live with it. And then these two terms are both sine theta multiplied by cos theta. And it doesn't matter which way around you write that, it's the same thing. That's crucial, that crops up later. And then minus cos times minus cos, 2 minuses make a plus, so that's plus cos squared theta. So that gives you that. And then you get a similar thing here. Just important to notice that whether you wrote that as 4 sine theta cos theta or cos theta sine theta, it's the same as this. So those two cancel out, and you are left with 4 sine theta and another, 4 sine squared theta and another sine squared theta. So that's 5 sine squared theta, and you've got 5 cos squared thetas. And so that equals this, and the thing in the brackets equals 1, so that's 5, which is what the right hand side was as required. There we go. And then the second one, and I've left this here, sorry, can't see it. I've left my working there just to show that you don't always get it right first time. Sometimes you have a go at something, it doesn't work, and you try something else. Again, considering the left-hand side, the right-hand side was only sines, so I needed to get rid of the coses. So that was a fairly straightforward substitution. Remember, this is one term, it's not that plus that. This is one term, and this is one term, so I've got to be particularly careful here. So I've multiplied that bracket out, sine squared x times 1, sine squared x times minus sine squared y. So here I've got to be really careful. So I've got 1 times sine squared y, which is sine squared y, but it's minus that. And then here I've got minus sine squared x times sine squared y, so that's minus sine squared x sine y, but that's minus as well, so that actually becomes a plus. So there's, I'm multiplying this bracket out, but then I'm multiplying everything by minus 1, because that minus is in front of that one term, so you've got to multiply everything by minus 1. That's a particularly fraught step, which is why I'm labouring it so much. Cancel out. So you're left with, which equals the right side. Good stuff. Okay, let's move on. So the process of developing our confidence with trig will continue throughout this year and year 2. So I can't say, yeah, we've finished trig, because it builds and builds and builds through the course. But we've finished what we're going to do for now with the identities and with equations. So, if you want more practice of that, well, A, feel free to ask me, but B, rest assured that practice is coming down the road. There's 2 more things we need to do. I did mention a quick recap of sine rule and cosine rule, which we're going to do. I said I'd do it in one lesson. I'm going to do it over 2 lessons, Thursday and Friday. And then we've got the graphs transformation stuff, so how you transform sine, cos and tan graphs. I want to do that when we're back in school, when I can see the whites of your eyes. So, and also I think, you can do too much trig in one go, so that will break it up a little bit. So 2 very quick lessons over the next 2 days, just recapping cosine rule and the sine rule and the associated formula to find the area of non-right angled triangles. So we start today by talking about the cosine rule. And for me, the cosine rule is all about corners. So we're now dealing with non-right angled triangles, just normal common or garden triangles. If I know an angle and the two sides either side of that angle, I can use the cosine rule to find the side opposite. And you may remember this labelling notation. We don't have any concept of opposite and adjacent and hypotenuse in a non-right angle triangle, so we just label our angles with capital letters, A, B, C, and the sides with small letters, A, B, C, and it's not random. You have angle and side opposite with the same letter. And the way the cosine rule is written, A is the side you're finding, and big A is the angle you know, but you can flick it around. So you could have B squared there and cos B, or C squared there and cos C. The other two letters can go there. However, because I like to remember one thing, I always write it this way. And when I'm presented with a cosine rule problem, however it's labelled up, I ignore the labelling and I ignore the I label the angle I know A and the side I'm trying to find little a. So I ignore their labelling and I superimpose my labelling. I'll explain that with an example later. And don't forget, we can rearrange the cosine rule to find the angle in a triangle if you know the three sides. So if I remind you, I'll tell you what, go on, see if you can remember how to do it. I want you to rearrange this so that it says cos A equals. Go on, pause and have a go. So I added 2bc cos A, that's one term, so I added it to both sides and I subtracted a squared from both sides to give me that, and then I divided by 2bc. So this allows me to find the angle if I know the other three sides, and it's important that I label the side opposite the angle I'm trying to find little a. The other two can be B and C, doesn't matter which way around. A couple of examples are probably needed just to remind you how we go about it, so let's go for that. So here's the first example. We are, and I have attached a handout. Don't have to print these handouts, you know, it's entirely, it's just some of you I know appreciate having the diagrams already drawn and realise I've done it on this side. I'm left-handed, so I apologise. I'm covering my hand, covering the picture with my hand. Right, AB. So remember what I said? The cosine rule is written with finding A in mind. So whatever this triangle is labelled, and strictly I should label that side little c, I'm going to abandon that and I'm going to say, okay, the side I'm trying to find, I'm going to call little a. So that means I'm going to call that angle big A, and so I can leave that as B. I'm going to call that C. So that's little b because it's opposite angle B, and that's little c because it's opposite angle C. So I've ignored their labelling and I've labelled it to fit in with what I'm trying to do here. Okay? So B, 8.4, C, 6.5, A, big A, 20 degrees. Go on, see if you can solve it for me. Okay, so that was the sum. B and C are interchangeable, aren't they? So if I decided that was B and that was C, doesn't matter. They will swap around. They make no difference to the sum. And so my answer 3.19, and that's centimetres, so rare use of units at A-level maths. And you know, I hope this is sort of flooding back to you. So let's do an example of finding an angle. So again, the angle I'm trying to find here is actually B. I'm going to ignore that. I'm going to label it A. So the side opposite is little a. That's C, so I can leave that and label that little c. That B, so that's going to be little b. Okay, so go back to your rearranged cosine rule. There it is. Write that in. So we've got cos A is equal to b squared plus c squared minus a squared over 2bc. And tell me what A is. Okay, and notice how I type it in on my calculator, so I just do it in one go. But I could have written, rather than writing cos A equals, I could have just written A equals cos to the minus 1 of all that. But you know, I'm just going to get the calculator to do the hard work for me. So 108.2, so I'm going to write 108.2099 ... equals 108 degrees. I mean, you know, we know that 3 sig figs is the default unless we're told otherwise. But this is just another belt and braces example there. And now, interestingly, this is an obtuse angle, isn't it? And if we look at our cast rule, between 90 and 180, sine is positive. So actually, the answer to this sum was negative. We didn't see that because we got the calculator to it in one go, but don't worry if you get a negative answer to that, because yeah, if you've got an angle between 90 and 180, the cos of that angle will be negative. And yeah, we got an angle between 90 and 180. Okay, so this is all a bit easy. Why is it cropping up at A level again? Well, let's have a look at a couple of slightly more involved questions. Okay, you may remember my favourite game. Where's the right angle triangle? Well, there's no right angle triangle here, but I can't actually see a triangle at all. So where's the triangle? We've got to draw the triangle in this problem, haven't we? And there's the added complication that we're dealing with bearings. So if you remember, the bearing is the angle that you turn clockwise from north. So we've got this plane is flying on a bearing of 040, which means clockwise from north, that's a 40-degree angle. And then when it gets 120 kilometres away, it turns to a bearing of 130. So it doesn't turn through 130 degrees, but it is now travelling on a bearing of 130, so that means it's going in that direction there. Calculate the distance of the plane from the airport. So that's the distance I want to find, and I'm going to call it x for now. So I need to work out some angles inside my triangle, don't I? And I can't just say that's 50 because that's a right angle, because it isn't. So this is a parallel line problem. Let me draw in a couple of lines to perhaps help us. I'm wondering whether you can now work out any angles. And don't forget to use the cosine rule. We need to know about a corner. So I've got two sides here. So really this is the only angle I need to work out. Okay, so actually that line wasn't really needed. See if you can work out that angle. I'm going to redraw the triangle over here without all this malarkey, but with just the angle there and the two sides and the angle I'm trying to find. Go on, pause and have a go. Okay, so this line means that that angle there has to be 50, making 180. And did you spot the alternate angle, the Z angle? So that angle there is 40, which is unusual, isn't it? So actually we're dealing with a right angle triangle. So actually I could use Pythagoras here, couldn't I? Let's ignore that though, and let's use the cosine rule, because actually it's probably just as quick. So I'm going to call that A, because it's now the side I'm trying to find, and cosine rule set up to find A, so I'm not going to call it X. So that means that's big A, and the other two angles are B and C, which means these two sides are B and C. Doesn't matter which way around. There you go. So I know that A squared is equal to B squared plus C squared minus 2BC cos A. Go on, off you go. So we stumbled across a right angle triangle, but the cosine rule we can still use it, although well done if you spotted that actually we end up doing Pythagoras anyway, because the cos of 90 is 0, so this term becomes 0, so we just end up with Pythagoras anyway. So, and there was nothing wrong with using Pythagoras once you spotted it was a right angle triangle, but I just wanted to use it as a cosine rule example. Okay, here's another example where there is no triangle. And this is because we're expected to draw the triangle. So we have a triangle where the three corners are going to be labelled ABC. So triangle ABC. But we're also told about angle ABC, which is the angle you get by going dot to dot from A to B to C. So, okay, I'm just going to knock up a triangle, all right? And I have no idea how accurate this is, and it doesn't matter how accurate it is. I'm going to call it A, B, C. So I'm told that A to B, the line from A to B is x, and the line from B to C is x plus 2, and the line from A to C is 5, and angle ABC, so that's the angle you get by going dot to dot from A to B to C, that is 60 degrees, and I've got to find the value of x. So hang on a minute, is this a missing sides problem? Am I going to use a squared equals b squared plus c squared blah blah blah, or is this a missing angle problem? Well, actually it doesn't matter, you can use either, because we're sort of, this is an algebra problem now, isn't it? I'm going to use this version. And I'm going to label up my triangle. So as always, I'm going to ignore how they've labelled it. The angle I know, I'm going to call that A. I'm going to call that little a. Leave that as C. So I'll call that B. Nothing wrong with doing that at all. I think as long as it's clear on your diagram what you've done, then that's brilliant. At the end, you know, well, no, I suppose you don't have to, because actually we're going back to just x, aren't we? But yeah. So go on, see if you can substitute those values in, and you're going to get an equation. That equation will involve x. How far can you get towards solving that equation? Okay, this looks a bit nasty at the moment, doesn't it? So I'm going to work on this. So I've got x, if I multiply this bracket by x, I've got to do 2b, which is 2 lots of that, times c, which is x. So that gives me, I'm going to leave the 2 where it is, that gives me x squared plus 2x. Okay. Why did I leave the 2 there? Well, what's cos of 60? If you look on your calculator, it's a half. So you get 2 of that times a half just gives you that, doesn't it? So I end up with that bit equaling that, but I've still got to be really careful. Alarm bells ringing, because that minus sign is effectively multiplying this by minus 1. So it's not just minus x squared plus 2x, it's minus x squared minus 2x. Let's look at this as well. So if I gridded that out, I'd get x squared plus 4x plus 4. Plus x squared, and that's... So I definitely feel a quadratic coming on. Some of you will have already got this far. I'm running out of space on my page. I tell you what, I'm going to move up here. Okay, so I'm going to have 25 equals, so I've got x squared plus x squared minus x squared. I've got 4x minus 2x, and I've got 4 there. Take away 25. And that's an equation that we can solve. Go on, go and solve it. Okay, so I get my 2 values, and you know I'm going to adopt a belt and braces approach here. So I'm going to say, okay, it's minus 1 plus or minus square root of 21, but x has got to be positive, hasn't it? So x equals minus 1 plus the square root of 22, and that rounded is 8.69. Sorry, 3.69. And that is centimetres. So a little bit of algebra in there. Probably not quite as complicated as the trig we've been doing, but you know, there's potential for a mess here, isn't there? So hopefully you were able to navigate your way through that. I'm going to say no more, just get you to have a go at that one. Now this is one where I might be tempted, because they specifically want me to leave, they're asking about cos p, I might be tempted to leave it as p and call that side little p, or call it a and that side little a. It doesn't really matter, but do you notice how in this one, and this one only because we were asked to show what cos p was, I wrote down the formula as I remember it, and I just replaced the a's. So I left b and c as they were. It doesn't really matter because this is the important statement. That's what they're looking for. And that all works out to be minus a quarter. No need to work out the size of angle P. They just want you to work out the cos of angle P. Okay, so there's loads of practice in the pure textbook on this. I mean, if you want some really basic practice, there's tons of it on page 177. There's some more tricky questions on 178. In fact, some of these we've already done. So the golf course one and this one were from page 178, and it goes on to 179 as well. And the question I'd like you to submit is the last one in that particular exercise. So it's question 17, page 179. And I know you can look up the answer, but I'm more interested in seeing your method. So if you could pop that on OneNote for me, you'll find the questions already on your OneNote regular submission page, or regular submission folder, sorry. Sine rule and area of triangles tomorrow, and then we are done. Okay, so this is not compulsory, this is just you doing as much practice as you feel you need. Okay, take care.